Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Kirk Gray.
Hey, Kirk, it's Fred Schenkelberg here, and welcome to 2022. It's been a number of weeks since we've talked, and although we schedule these and batch them ahead of time, and for our listeners' enjoyment, it's been 45 minutes since we started this call, and we spent a couple minutes catching up.
And we both switched computers.
And we've reloaded software, and we've, Control-Alt-deleted this way and that way. But it brings up a topic, and it's just top of my head here, Kirk, is,
yes.
When do you do enough failure analysis that you just fail and try a different solution altogether? I mean, to think of it.
Yeah. First, I started on my desktop, and you were on yours, and we had this echo problem, and I switched to a laptop, and we still had the echo problem.
And then I switched to a different computer, and we still had, then it cleared up.
It cleared up, but you had issues with the call recorder on your...
On the recorder side, it wasn't compatible with the current version of the Skype package, and so it took 2 installs for that. And this is a quick summary, because at first we were checking settings, and then we were trying, let me try calling you. Sometimes just a second call works.
Right.
So we went through let's try to isolate it. Let's try to troubleshoot it. What are some of the quick fixes we know worked in the past? And, I was like, all right, but trying to make it work is a great way to troubleshoot it because we were active in the system. If I look at just my system, I'd have to figure out somebody to call to see if it's working. And since you were already here, let's try that. But the point is though, and you've done this, right? You get an interesting problem or an interesting detail or something that's going wrong in a test or something's going wrong with a customer. When do you stop the failure analysis and go, we just don't know?
Sometimes the problem can disappear. I mean, in troubleshooting, by troubleshooting itself, suddenly you've actually moved apart. You've reconnected something that wasn't connected. You didn't know it. And you really can't troubleshoot anymore. It works. Now, we went from my computer a couple times with your computer, recalling each other in different you calling me, I calling you. So I think that in this case, we've kind of isolated. I mean, that's trying to isolate where the possible cause of the problem was or is a big part of failure analysis, of trying to understand. So, we don't
understand it though. We got one of our various combinations to work, but we don't know why the other ones weren't working.
Exactly. And I would say the next step for you would be to check with somebody else if that echo is happening on when you call, because I had 2 computers. It came through the same way, but it wasn't until you switched to this other computer of yours that this problem disappeared.
Well, it underlies the concept, though, which is completely unrelated to troubleshooting, is redundancy is actually a pretty good thing. It allowed us to do our recording today.
Exactly.
But we spent 45 minutes.
But that cost a lot. We've got to.
I know. But it's the nature of our work, and
redundancy is expensive.
It is.
Yeah.
But for in practice, you're exactly right. If I'm troubleshooting stuff and I disconnect and deconnect or I reboot, if it's software, a lot of times that clears registers. It does all kinds of stuff that could be an issue.
Right. Yeah.
And what I find that wholly unsatisfying, because that process almost never tells you what you did that worked. And just a reboot is like, well, I don't know what changed, but it's working, so don't move on. I think that attitude is dangerous. you know.
Well, the attitude is dangerous, but there's nothing you can do about it. When I was working on ion implanters, linear particle
Right.
accelerators, or semiconductor equipment, very complex room-size systems that
Yeah.
sometimes I would take something apart and then put it back together, trying to troubleshoot it, and it worked after I fixed it. I mean, after I put it back together,
Yeah.
trying to isolate the problem. And of course, I might have tightened something. I want to reconnected a connector, and there's nothing further you can do.
Right.
You can't, unless you can recreate that. Now, obviously, a sample of one is not very good. If you just had a failure of 1 out of 3,
Or if you have an intermittent failure, that's really
or
tough.
an intermittent, right. You've got to be able to stimulate it to cause the failure again, and that can be very difficult to do. But that's why you've really got to be doing quite a few units, I think, to ensure that you've got it. But
I'll get you to be a statistician someday, Kirk.
yeah, I know. No,
but you're
no
right.
question.
You're right. There's,
3 samples is not going to tell you everything, and
Yeah.
you need to realize that again it does take some numbers. But I think that you try not to stop. If you do, I mean, if it's working, you can't fix it. You can't troubleshoot anything that's functional, working, working.
And we were able to recreate the issue, and the way it worked, what you were experiencing, and I couldn't hear it, was that
Right.
as I was talking, it would, let me see if I can recreate it here. It would reverb.
Right.
It was over. Oh,
Right.
Do it again.
Right. It would be like a second echo bounce back, some kind of feedback loop, or delayed latency,
Right.
repeat.
So if we were creating this system, right, and the Skype is just one piece of the system. So there's our computers, there's the networking equipment, there's routing. It's a magic that it works. But we would have to have oscilloscopes and all kinds of route tracers, and our software on both sides would have data logging and what's happening, what's going on, all the way from what's coming into your headset, your speakers, and what's the signal that generated it, and all the way back. And that would be amazingly expensive and complicated in itself to do, if we even could do it. If we're in a lab, we might be able to. And a lot of times we create systems, and especially software systems, where they have a data logging type thing. So every action, every command is done, and you create this massive document that you can search through to search stuff out. But as a layperson using Skype, we don't get that data logging feature, much less know what to look for.
No. And it's a challenge. I mean, it's a big challenge in the final testing of a desktop computer, and a company I used to work for. And they'd have 30 laptops running, and I had a few in a thermal chamber to try and stimulate, especially software failures and reboot, and they would just be rebooting, and then suddenly you get what we always call the blue screen of death.
That's right.
BSOD, and when that happened, that was like mining gold. It was like Bitcoin mining. Bingo! You hit something. You
hit something, and you get into the logs and everything else, and you find that there's this one register, or this one memory thing, or this one thing timed out, or
this is what we had to do. Is I took out the batteries in the thermal chamber just because they didn't need to be in there, and had to run on AC. But I didn't. You wanted to make sure that you didn't lose that screen, because once you lost, so we would put the battery in, and I would carry the laptop still running, make sure I didn't close it or whatever, still running to the software guy that did the BIOS, and he could then tap into that and look at the whole log and reproduce what had happened. Or he could look through this, very detailed code and stuff, and see what had happened. And that's the way he figured it out. But it was just a really almost a random chance that it would happen, and it was very infrequent.
Yeah. But let's go back to the point. Let's say you're in a factory and a piece of equipment is malfunctioning, or you're creating a product and you're in, whether it's Halt or wherever, and something's not working.
Yeah, any test.
Any test. I mean, the basic process is, can you reproduce it? Can you say, if
Right.
I do this, it
Right.
fails? And you and I have both used like cold spray and hot spray,
Oh,
stuff on
absolutely.
things,
Yeah.
and let's cool
Yeah.
that, let's heat that, let's take a look at it. I like to start with the stuff that doesn't damage stuff or disconnect things or cut things apart. But at some point,
Well, obviously, when you start doing that, you've broken the integrity of the system. So
right. But you start where you can, and let's say we get it isolated. And I remember one I did. It was a crystal, a metal can encapsulated crystal, and
Right.
and the crystal failed. We could tell the crystal was not functioning. It was broken. It had an open circuit basically inside the can, and we were both looking at it. My buddy and I were looking at each other, going, "The inside of this component is two little plates with a crystal soldered to it.
yeah,
There's nothing else in there."
right. Very simple.
Yeah, and so we cut it open, and sure enough, the crystal was broken. And we're like, "How in the world did that happen?" And then it was, now we knew the failure mechanism, and that was our problem with this sound issue we were having, is we didn't know the mechanism, what was causing that to occur, and so part of the search was for, well, what's causing this? What's the underlying mechanism? And then once you know the mechanism, that might just be the start of a whole nother operation of, well, what could cause that? What would make that fail? And so we, and long story short, we figured it out, and it was a manufacturing defect. But
we had the same thing happen at Story Technology, I believe, and we through X-ray of the crystal can, we saw that, and I think it was dimensionally the soldering or the attachment to the crystal was incorrect.
Well, yeah, you must have had the same vendor we had.
Maybe we did. That's probably the same time back in the 90s or whatever. But anyway, that's definitely something that is was very stimulated. I believe we stimulated that through thermal stress.
Yeah, but the idea is that once you know the mechanism, then the next question is then, well, what set of forces could create that mechanism to manifest? And then sometimes you even get into, well, was it a manufacturing process, and what allows that process to vary that much? Or is it a decision in the design that we decided to put that component at too close to here? Or is this timing was set inappropriately? What part of our process allowed us to make those mistakes?
And what is the history of that component? Did it work before in the original design and you didn't have any problems, and then suddenly you started to see cracking crystals?
Right.
Because then that would say, they've got a manufacturing issue, which it ended up being. Yeah. And the same case with us.
But but at some point, I mean, part of it is if you're in development, right, in your early prototypes,
right,
and there's a lot of opportunities to go figure out what failed, because generally, in my experience anyway, a lot of things fail, and because we're still trying to get this thing to work and to work as we wanted, and we're making compromises, making changes, and but that part is often, well, I think if I do this, it'll work, and then you go experiment with it, and then move on to the next one. You have just too many things to go fix.
Right.
But once you get to the field, it's a different set of constraints, right? We don't really know what was the circumstances unless you have tons of monitoring on your system. You don't really know how the customer was using it or where they're using it, and all those things, and what its history was. And you have all the added manufacturing variability that is limited to some extent when you're in prototyping. It's sometimes very hard to get in some industries, you don't even get the product back to do troubleshooting.
Right. Low cost devices sometimes are thrown away. Yeah. And, so you never know unless you really have a significant percentage. And then, in a Pareto, you definitely address that. But, it's that's the difficulty of using field data, is a lot of times if the customer does misuse it, or pushes the wrong button, they may not admit to that.
Or may not even know they did.
I may not even know they
that's
did.
the way it
Right.
should work. And well,
Right.
I just posted an article. It should publish on Monday, which will be a couple weeks ago from when this podcast gets posted. But look for an article by Larry George that's on what cost. What costs the right data? What is the cost of not having the right data? And it's basically that idea of if you really need good field data, then you have to invest in actually getting good field data. If you,
Right.
It's the same when we go to the lab to do testing. If we just throw the devices in the chamber and walk away and come back later and go, oh yeah, they're not working or not working, we're not going to learn as much as if we invest in getting good data, monitoring it as we go, or checking things like that.
Exactly. Right. And that's where I say it's not throwing it in a chamber, doing halt, just step stressing is planning what you're going to monitor, what you're going to look for as far as the change or what you expect. And, basically having the right sensors in the right places to know what's going on with the product and running the right software routines. A lot of times, previously I would see them run tests that would test each section, say, of a computer individually. Is a graphic card working? Is this working?
Right.
But the real issue maybe comes when the whole computer is interacting, is you're accessing all kinds of parts of the computer.
Oh yeah, we used to call that the white problem. It's the white space between the individual qualified components. It would be the timing between the hard drive and the motherboard. They wouldn't be happy with each other.
Right.
Even though both are in spec, right?
Right. You ask the hard drive, are you reading and writing correctly? Yes. And you go, and that's the way this sequence of test suite went. And I said, no, let's get these comprehensive running of all the system together interacting.
Yeah.
And that would be a much more comprehensive test. But
it is. When I was working with a division at HP that was making kind of business level desktop computers at that time, and they said, well, we got to look at the math here because we have 6 different hard drive vendors that we could use, and they have 8 different, sizes and configurations to them.
Exactly.
And we've got 3 motherboards, and we've got 5 optical drives, and we've got 4 monitors, and
that's 10 to the exponential, right?
Yeah, it's 10 to the too many units.
Yeah.
Because in the issue, so they ended up doing, based on their history with the different components and vendors and stuff, is they looked at what were the field problems, which configurations had the most issues in the field.
Right.
And that narrowed it down to like a dozen. And then they would make those as kind of, these are our worst case. And even then it was really, 1 in 100,000 would have a problem. So it was luck when they found it in the unit. The other strategy they used, and it worked for some of their systems, they would use the ones that were like the fast chip, slow chip kind of approach.
Right.
We would use operate the memory card at the low end of its voltage, just to stress it a different way, and then we'd operate it at the high end of its voltage, or we'd put in different crystals, different timing circuitry,
right, different bus speeds and things like that you could do.
Right.
So that'd be like you're talking about 4 corner testing, but in dimensional 4 corner, where you'd put the lowest speed processor under the highest load, or those kinds of things, where you combine corner conditions as much as possible.
And it ended up being, even with all this strategy and all these different ways to make things, and they were making incremental improvements and making their design more robust. What they ended up finding, though, is that somewhere along the line, some material or some process changed subtly, and it adversely interfered with another program, another component or piece that was just subtly changed, and then we have a spike of failures from that one set of configurations, and it was like whack-a-mole. is the way they described it, because these two things are not happy with each other, but if we swap out that hard drive for this other vendor, it's fine.
Right.
It works just fine. And
Right.
and all over the map. And it was so many different permutations to it. I'm trying to use some fancy stats words here for you, that it was really tough. But the overall strategy of just making the systems more robust to timing, to speeds, to temperatures, whatever. I mean, just make it more robust, which is really what you and Greg Hobbs have been talking about for decades and decades.
Right. And ensure that's always there. That robust level of strength is always there. And behind the scenes, while you're doing all this, with testing and everything, there's a bunch of procurement guys in each one of these companies and each level.
Yep.
There's a cheaper epoxy to, use an encapsulant. There's
Yep.
there's this other guy that gives me the parts that's exactly the same spec. All these things that are going behind the scenes because every manufacturer of every component in that box is trying to make it less costly, more efficient, whatever.
Yep.
And they could be changing things that said, well, it was a little change. We didn't take it. It really didn't affect, most of our.
That's what we can do, Kirk. That's it. I think you just hit on one of the things we got to experiment with this, because we're still in, supply chain constraints, and there's COVID
Right.
shutting
Oh,
down
yeah.
factories,
Right
and,
now.
and companies for the last 2 years have been, struggling to get whatever they can get to make it work and ship it. And so that's it. There was a router somewhere in the network here that between us that was using a duplex instead of a simplex device,
Right.
and it was doubling up my voice. That's
There
it.
it goes.
That's it. I got it. That's the solution.
We found the problem. Now we just got to go find that router of thousands in the chain. Yeah.
That's right. But who knows? The part of it is brainstorming. And part of it is investigating. Look for the failure. Can you replicate it? Can you do this stuff? And sometimes you just can't get there from here.
No. And in our situation, I think we got, just the preliminary, what we went through for the 30 minutes trying to get this call. I'd say right now the focus would be on your desktop, the original computer.
The original one, yeah. So
because
I'll run some tests.
We changed 4 computers, or we worked with 4 computers.
Yeah.
And it seemed that once you changed out of your computer to another one, that's when the problem resolved. So that would be the first step, say, okay, I'll go back to my original and see if I can call somebody else, and we get that echo.
Yeah.
So yeah, it's always a big challenge. I mean, this is really tough. And failure analysis, sometimes you do end up saying, I can't find it.
We don't know. Yeah.
We don't know. We just hope that we can reproduce it, or somebody comes up with a similar problem. And that may unfortunately be in the field if you don't do enough testing, or, try to reach the fundamental limits of technology, or achieve as much as you can when you're in development.
So we gave it a stress test. We've yammered on, and it sounded like it's working on both ends for 20 some minutes. So that might be a good time to, make sure we don't stress it too much and end up having to scrap this recording.
Yeah, I could get overheated or something.
That's right. All right. Well, there's, it is a real issue is, well, how much do you really do troubleshooting? And if you're listening to this and, run into this, or if you have an idea or a guideline that you find works, or how do you know when to stop, I know my personal experience, it was when my boss said, stop doing that, move on to something else.
You spend enough time.
I can't let it go. I can't let it.
I know. Really frustrating for us.
It is. But let us know. Head over to accendoreliability.com/go/SOR. You can find a SpeakPipe widget that lets you record a voice message to us, or you can leave a written message. You can also find Kirk and I and the other hosts over on LinkedIn or on Accendo reliability.com with our about pages. So there's lots of ways for you to join the conversation, and we would really enjoy hearing from you and adding you to the discussion. So with that, Kirk, let me hit the stop on the recording and let's make sure that works. And then we'll talk to you again soon.
I hope so, Fred. Okay, talk to you again.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.